Students will be able to determine the convergence of a term and a series. Write the Maclaurin polynomial for sine of x. Well, sine of x is an odd function, so the polynomial is the odd powers. It is alternating, and we have the odd factorials in the denominator. So to write the nth term, we have negative 1 to the n plus 1. This starts out with a positive value, but I really want to start it with 1 because this down here is 1 factorial. Then we have x to the 2n minus 1. 2n makes everything even. Minus 1 makes everything odd. So then we have over 2n minus 1 factorial. Here it is written in summation notation, and the convergence is all reals. The next one, cosine, is an even function, so we have the even powers starting with 0. This also alternates, so we have negative 1 to the n for the general term, or the nth term, and then x to the 2n over 2n factorial. This also converges for all reals. And then we got e to the x, and all of the derivatives of e to the 0, or e to the x is e to the x. And then e to the 0 makes all the coefficients 1. So we just have 1 plus x squared over 2 factorial, and so on. The nth term is x to the n over n factorial. And then in sigma notation, n equals 0 to infinity of x to the n over n factorial. This also converges for all reals. Then f of x equals 1 over 1 minus x is the power series, that is x to the n. This only converges between negative 1 and 1. And then with natural log of 1 over x, I wrote out all the derivatives, and then here is the polynomial over here after you cancel out some values. So this becomes negative x to the n over n. They're all negative, so it's not alternating. We don't have negative 1 to the n, it's just negative. For each problem, does a sub n converge, and does the series converge? So for this one, if we do the limit as n approaches infinity of the nth term here, it's 2. So the terms are converging. They are converging to 2. But since the terms are not converging to 0, we can say diverges by the nth term test. The next one is a geometric series. But the terms are headed to 0. That means it has a chance to, the series has a chance to converge. And then on letter B, R is 1/3, the ratio, which is less than 1. And we can say this converges by the geometric series test. Down here, the terms now are headed to infinity. And we could actually say that this diverges by the nth term test. But we could also say that r is 4/3, which is greater than 1. And we could also say that this diverges by a geometric series. Find a power series to represent the given function and identify its interval of convergence. When writing the power series, include a formula for the nth term. So this looks a lot like the power series, or really the formula for the geometric series. And we need 1 minus, though. The formula for the geometric series is a sub 1 over 1 minus r. Well, we have 1 over 1 plus. We can write that as a minus a negative. So a sub 1 is 1, r is negative x plus 2. So here's the power series, and here's the nth term, and here it is written out in sigma notation. Now let's get the identify its interval of convergence. So let's do interval of convergence. And what we know with a geometric series is that r, the absolute value of r, has to be less than 1. So then we know that negative 1 is less than negative x plus 2 is less than 1. And if we divide by negative 1 and then flip all the signs around, we just get this exact same thing. That's a 2 and less than 1. So then we just subtract 2. So negative 3 is less than x is less than negative 1. So there is the interval of convergence, and we can write that. I usually write these as interval notation.